Hello, algebra. This is today's lesson for you guys. On Monday, we will be finishing, or actually, not like finishing, but the notes that I gave you guys yesterday. You might have noticed it was labeled like part 1. We're going to be doing part 2 on Monday. This is graphing lines in slope-intercept form. And I just want to talk about slope-intercept form a little bit. Slope-intercept form, best form, superior. Love it. So all these problems on here will be slope-intercept form. And all we have to do is sketch the graph of each line. And we did sketching the graph of lines yesterday by putting our points in the table and then doing what we needed to do and plotting those points and then making the line through them. But we'll notice that none of these problems, there are 12 problems here, none of them have a table. And I could give myself a table. I could draw a table in, but there's an easier way to graph a line when it's in slope-intercept form. It is called slope-intercept form because it gives you the slope and the intercept. So remember, slope-intercept form is y equals mx plus b. That's the intercept. That's the slope. The slope is m, the intercept is b. So if I'm looking at this first problem, y equals 7/2 x minus 2, this is going to have an intercept, and when it says intercept, it means a y-intercept, not an x-intercept. So it's going to intersect the y-axis at -2. So that's my intercept. And make sure we are paying attention to whether it's a negative or a positive. And this is my slope. And remember, slope is the same thing as rate of change. So instead of plotting all those points, I mean, that would absolutely work, but I think there would be a limited number of points you'd be able to graph on here. Pretty sure, at least. So I just said my intercept was -2. And my y-intercept, my y-axis is the vertical one. So I'm putting a point at -2. I automatically know it's going to go through that point because it's in slope-intercept form and my intercept is -2. All of these problems that you will see here are going to be just like that. Where that number on the end will be your y-intercept. And then we have the slope. As I said, slope is the same as rate of change and we did say rate of change was, I'll come down here, rise over run. So if my slope is 7/2, then the rise is 7, the run is 2. So from this point, from my intercept, I'm going to go up 7. So 1, 2, 3, 4, 5, 6, 7, and over 2. And when I say over, I mean to the right. So to the right 2. So that gives me a new point at 2, 5. So now I have 2 points. And just like yesterday, when we were talking about how once you had 2 points, you could figure out the pattern that was going to happen. With graphing like this, once we have 2 points, we can figure out what the rest of the line is going to look like. Because all the points on this line are going to be in a straight line. I don't need to figure out other points. If they give you a table to work with, you should probably use the table and, like, you know, figure out some other points, more than just 2. But with slope-intercept form, you find that intercept, and then you use the slope to determine where your next point is going to be. And then once you have 2 points, make a line, a straight line going through those 2 points, and you're good to go. Okay, so we will look at another example here. Number 2, I have y equals negative 6x plus 3. So this one, my slope, I'll just call it m because that's the slope, and positive 3 is my y-intercept, my b. So since that 3 is hanging on the end there, I'm going to put a point at 3. There's my first point. My slope here is negative 6, but that's not a fraction. That doesn't really have a rise or a run. But I can make it a fraction because negative 6 is the same as negative 6 over 1. So my rise is now negative 6. My run is 1. So that's my rise of negative 6, my run of 1. And a rise of negative 6 means you're just going down. And if it was, let me try to find an example, if there are any on here. Oh, so like this one, if I have the negative in front of the fraction, the 1/3, just pair it with the numerator. So it would be a rise of negative 1 on this one and a run of 3. A rise of negative 1 and a run of positive 3 on this one. So just pair that negative with the numerator. But anyways, from this point, I said I had a rise of negative 6 and a run of 1. So I'm going down 6 from this point. Down 1, 2, 3, 4, 5, 6, and then over 1, or to the right 1. And that's my new point at 1, negative 3. So now I have 2 points, and I can make a line through those 2 points. And that is what the graph of negative 6x plus 3 would look like. And like I said, we could make a table, but if you look at this, you can tell that the only points that are actually on this graph that would fit in that table would be 0 and 1. If I try to plug in 2, well, that's going to be off the graph. If I try to plug in negative 1, that's going to be off the graph. So, you know, the table would only have 2 values in it, so that doesn't help me as much with a problem like this. But yeah, just put your y-intercept and then use your slope to find out where your next point is, make a line through those 2 points. That's all you have to do when graphing from slope-intercept form. Looking at number 3, this is just y equals 5. There is no x. So it's like y equals mx plus b, but since there's no x, it's like y equals 0x plus b. So our slope is 0. Our m is 0, and this is our b. But with anything like this, it says y equals negative 5. So I'm going to go onto my y-axis and find negative 5. So there's negative 5 on the y-axis. And I just want to make a line that is going to go straight across, because that is just going to be a straight line. guess I should probably add arrows on the end. But that would be the entire answer for this one. You just put a point at y equals -5, then go straight across. With something like number 6 here, where it's x equals 5, you would put a point at 5 on the x-axis. And if it's x equals 5, instead of going straight left and right, you're going to go up and down. All right, I'm trying to see if there's anything else or any other problems that I want to go over with you guys before letting you work on this. I do not think so. I think that explanation should suffice. For number 7 here, it's just y equals 5/3 x. We see there is no b value. It's plus 0, meaning that you're going to put your first point at 0 on the y-axis, and then your rise over run, you're going to be going up 5, right 3 to put your next point, and then there you go. And actually, hold on. Trying to remember, I feel like there was one thing when I did this assignment last year that threw people off. Yes, this one, number 12. So number 12, 2x plus 5, my y-intercept is 5, my slope is 2. If I try to go up 2 over 1, I can't. It's off the graph. So if I try to go up 2 and right 1, that doesn't work. But what if I just do the exact opposite? What if I go down 2 and left 1? That does work. So typically, you would want to go up and right, but if you can't go up and right, go down and left. If it's positive slope, of course. So yeah, that would be your second point for number 12. Anyways, that's today's assignment. Hopefully that explanation is good enough. I will see you guys Monday.